Hello and welcome. In this video, we will look at how a differential pressure control valve works. We will use an STAP type of DPCV, but only because this valve shows the functioning in quite a straightforward manner. As you might know, a DPCV will try to keep a stable differential pressure across a load, no matter what happens in or before the circuit. This could be a changing available differential pressure because of other circuits opening and closing, or the valves in the circuit opening and closing. But how does this mysterious valve do this? To fully understand this, we must look at the role that the different pressures are playing. The P1 pressure is the high pressure on the supply side of the circuit. Via the capillary, this pressure is communicated to the high pressure chamber of the DPCV. The P2 pressure is the low pressure on the return side of the circuit. This pressure is applied on the bottom side of the membrane. And then we have the P3 pressure, downstreams of the DPCV. Now, you might remember or know that the static pressure is actually a force applied on a surface. When thinking about that, we now know that the P1 pressure is applying a certain pressure on the surface of the membrane. So this will cause the valve to close. Same reasoning for the P2 pressure. This is an upwards force applied on the bottom side of the membrane, causing the valve to open. And the first force difference is established between the two forces. But then how do we keep a specific DPL? This is where the spring comes into play, actually the spring force. By tightening or loosening the spring force, we set a certain equilibrium. This equilibrium being related to the needed DPL. By rotating the setting screw clockwise with an Allen key, you tighten the spring. So the pulling force applied on the membrane gets higher, causing the valve to open. By turning anti-clockwise, you untighten the spring, which will make the valve close and decrease flow. Once a specific spring force is set by doing this, the valve will keep a stable differential pressure across the load. Now, let's repeat to make sure we completely understand. A DPCV keeps a stable differential pressure across a load. The valve does this by opening and closing, taking the excess differential pressure or releasing some differential pressure back to the system. The functioning behind is a play between three forces on a surface internal to the DPCV. These forces are respectively the P1 and P2 pressure and the spring tension. Make sure you look at the other videos related to this topic to know more about the differential pressure control valves.